Juno, or like, can you hear us? Woohoo! I see a thumbs up in Fairbanks. Awesome. Thank you. Yeah.
Cool. Yeah. All right. So thanks everybody for coming tonight. This is awesome. Getting people to show up on a sunny Thursday afternoon can be quite challenging, but we've got a pretty full house here as well, which is super cool. Raise the roof, Anchorage. And also Fairbanks, you guys are killing it. There's at least 3 people there.
Nice.
And shout out to Conroy and Juno. So I just want to touch on a couple of things. Some just like organizational housekeeping. So for those of you who don't know, my name is Jeff. I'm the organizer of the Alaska Developers Alliance. One of the reasons I created this group is to bring people together from disparate places. It's been a really interesting and cool process to get this put together, but just over a year, we've now got 3 chapters in Anchorage, Juneau, and Fairbanks. We've got 177 people in our Slack channel and over 200 on our mailing list, and we get like more than 50% opening the email, which I think is pretty epic.
That's amazing, right?
Yeah,
From what I understand.
Thanks. But a couple other things have happened in the last month that I want to talk about that are super cool. So the first one is that Launch Alaska, which is an accelerator here, a startup accelerator. They're focused on energy companies and renewable food sources and things. They've taken us under their wing as our nonprofit sponsor, which means we can officially take sponsorship, and it hopefully won't literally be my credit card buying pizza anymore. But thank you all for eating it. And also another milestone we hit was I actually ordered the right amount of pizza this time. The last several times I've had many boxes to give away. So thank you for coming and doing that. What that means for the Alliance though is A, that it's official, and B, that we've got an opportunity to do some really cool things in the future. One of which is that we're going to have a 3-day completely free boot camp for Golang. So I don't know who's familiar with that, but that's actually where I met Anjana, who I think, did I get your pronunciation right this time? Okay. I flew down there last October to take this course down in Arden Labs. The guy's name is Bill Kennedy. He's a phenomenal instructor. And one of the things that was really cool about this course was that it was more focused on using Golang as a tool to teach you good engineering rather than the semantics of the language itself. So if you are somebody who has been existing as a programmer, hanging out in the trees of Alaska, kind of by yourself, soloed, and you haven't had a chance to level up recently, I highly recommend it. It's going to be coming in September, and it's the weekend of the 13th. It'll be a full 3-day course. Rest up. It's a lot to get in your brain. But he's a phenomenal teacher, very engaging. So that's one thing I'm really excited. I'll have more on that coming soon. The other thing is that we actually have a real budget. Launch Alaska has given us $8,000 per year for the next 5 years. Nice. So yeah, one of my core goals with creating this group was to make it sustainable for the long term, and Launch Alaska sort of just popped up and like hardcore committed to that. So you guys are all a piece of this. Fairbanks and Juneau, you guys are all a piece of this. Thanks for coming on board with us. So some of the things that I'm really interested in doing are helping to support the solo developers who are not working with companies or who are maybe focused on entrepreneurship and don't necessarily have a chance to travel outside. So we're going to use some of that money to provide scholarships for developers to come and attend some of these boot camps, help get them involved in the community, throw hopefully more boot camps. We're going to be sending out a developer survey. So we do this once per year to sort of find out what the makeup of the ecosystem and our groups look like. We got a lot of really interesting feedback out of that last one, which has completely shaped the direction of the group. So along with becoming officially affiliated with Launch Alaska, we finally got a draft of our white paper out on why we're doing this and who we're doing it for. So if you go to akdevalliance.com/paper, you can read up on that. And if you go to the website at the bottom, there's 2 other documents. So we've got our white paper, so businesses and organizations and corporate can find out about us. And then we've got our action plan about specifically what we're doing, and then sort of our manifesto on like what's our plan going into the future and where do we see the Dev Alliance in 2021. So check that out. If there's something that you feel really passionate about, this is a group by developers for developers. So get involved, give me some input, keep an eye out on the newsletter and just participate. That's all we ask. Other than that, the next big milestone is that this is our first speaker from out of state. So that I think is super cool. I'm really excited. To me, this feels like, I guess, somewhat of a surreal moment to think like, you know, a year ago we had like a couple people getting together in a room, and now we've got 3 chapters. So big shout out for that. And the last thing before I introduce Anjana is that last week we had our first game developers meetup, and that was cool for a couple reasons. One of which was because I didn't plan it or organize it. The other was that there were some people who were involved in that community, Jason and Barrick, who had been previously putting that on and hosting that meetup. I believe it was at a coffee shop previously, and it was
Pilates by REI.
Yeah, so it was the Pilates by REI in Anchorage, and they just said, hey, every Tuesday we'll be here at this time, and it existed for quite a while. But those things are really hard to get momentum and really keep going. And as we've seen in previous groups, you know, if it all relies on one person to get everything organized, eventually like life happens. Yeah, so I just want to also throw this out there that the Developers Alliance really wants to help support anybody if you've got an idea for something that you want to make happen, whether you're in Juneau, Fairbanks, Anchorage, or Gerwood. I know there's a couple of people hiding out there. Just let us know. We're happy to make it a Developer Alliance branded event, happy to get pizza or food and beverages there. Just let us know. We're totally open to it, and if we can, we will blast out emails and post it in the events channel, but just come participate. So, all right, that's enough talking for me. I want to introduce Anjana. She's a developer and does developer outreach for Mapbox, which is a really cool company. That's what our last talk was on. If any of you missed that and want to check that out, it'll be posted online. It's live streamed on Facebook, and we should have it up on YouTube once YouTube decides that our organization is old enough to give us a channel. So, without any further ado, Anjana Vakil. Thanks.
Thank you so much. Thanks. Hi, everybody. I'm Anjana Vakil. I'm super stoked to be up here and to be meeting you all and to be, it's a huge honor to be the first out-of-state speaker. I hope the first of many, and I hope you all come down and visit us. I'm based in San Francisco. I work for a company that has offices and folks all over, including Portland, Seattle, all up and down the Western Seaboard and the Eastern. So really excited to be here. And as Jeff mentioned, I'm a software engineer, and I also do a fair bit of outreach and education and things like that. So I'm really excited about like learning and teaching anything related to code, especially different languages. That's what I'm going to talk to you a little bit about today. And I don't come from a background in computer science, so I got into this field through the field of teaching, and I really find that like I learn best when I teach things to other people. So I hope that I love to see communities like this that grow to be venues where people can say, hey, I learned this cool thing recently. I want to share it with everybody that I know, because I find that to be not only great for the community building, but also great for internalizing those ideas and really learning them. So what I would like to share with you all today is a kind of a big picture, like philosophical outlook on some things that I've learned about programming in the last few years. I've sort of been doing this professionally for about 4 years now, I guess. And I have found that programming paradigms has been a really useful level of abstraction for me to look at programming through the lens of. So that's what I want to talk to you all about today. Just briefly before we get into that, so yeah, I'm Anjana Vakil. You can find me on Twitter at my name because I'm bad at coming up with clever internet handles. So that's boring, but useful. And I really love to, like I said, think about the communities that we create as we go through our learning journeys as programmers. So I like to give a really quick plug for some of the communities that I have grown with and without which I wouldn't be here. I wouldn't be traveling to places and meeting Jeff on airplanes and ending up here speaking to you all. So I work for Mapbox, as some of you may have just learned in the talk a while ago. But I think Mapbox is one of these really great companies that is committed to teaching and to helping communities grow. So we love to be involved in local meetups and local things like that. And we are always hiring, so reach out. But we also, we make some mapping tools, which you can hear more about in the recording of the talk that we just gave if you weren't in it yourself. And we're always interested in seeing what other people are doing with those. So please reach out if you have worked with Mapbox or are curious about it or in any way. Before I worked there, I got the immense privilege of working with some amazing communities, one of which is called the Recurse Center. This is a community in New York City that is, you could kind of describe it as a writer's retreat, but for programmers. It's like a programming retreat. It's not a boot camp, but it is a place you can go for 3 months and get better at programming. But there's no courses, there's no teachers, there's no curriculum. It's just a space and a community of people interested in leveling themselves up. So it's a completely self-directed program and essentially a network of folks in a physical space where you can go and investigate whatever you're curious about in the world of programming. You can go for 3 months, as I said, or 6 weeks, or even 1 week. They have occasional little mini batches, they call them, and dig into whatever you want to dig into to level yourself up. So whether that be like learning a new programming language or building that game that you've had in your head forever, or switching it up and working on a totally different problem than what you work on day to day if you're a developer, or even working on some computer science fundamentals if you're like me and don't have a background in it and need to fill in some gaps in your knowledge. So it's a really cool space. It's free. There's no tuition because there's no curriculum. It's living in New York is not free, but luckily they have grants for underrepresented communities in tech to cover the living expenses. And it's just a really phenomenal community of learners. So highly recommend checking it out if that sounds like up your alley. It's recurse.com. You can read all about it. Can't recommend it highly enough. I also had the really good luck to be involved in another amazing community dedicated towards making it easier for women and other underrepresented minorities in tech to get involved in the free and open source software community, the FOSS community. That's called Outreachy. It's like outreach with a Y. It's an organization that essentially coordinates paid remote internships at a variety of different projects and companies that work on open source. So for example, Mozilla is one where I did an internship. They work with things like the Linux Foundation. They work with some companies that have huge open source projects, all kinds of different things. Some of the internships are around coding, some of them are not, some of them are around community building or documentation or all kinds of different stuff. So if you know anybody who's looking for a way to like kind of get a foot in the door in tech or in open source particularly, please send them to outreachy.org and have them read about like how this program works. They run sessions twice a year. It's open to people globally, and again, focusing on people from underrepresented communities, women and other underrepresented groups in tech. And if you are a maintainer or like work at a company that maintains open source software and want really awesome interns who work for you remotely and just like finish that feature that nobody on your team has time to do, also check out outreachy.org. It has all the information about how you can get involved as a project sponsor. So as I mentioned, I did an internship at Mozilla a while back, and I'm still involved with Mozilla community. I love Mozilla, I love the open web and the open web technologies they work for. And I'm still involved with them as a member of the Mozilla Tech Speakers. This is like a volunteer group of folks who go out talking about open web technologies at events and meetups and things around the world. And it's a really cool program. They basically give you some public speaking training and also some briefings on new developments at Mozilla and some of the new web things that they're cooking up. So yeah, if that's the kind of thing that sounds interesting, also check out Mozilla Tech Speakers. Yeah, you can Google for it, but it's like events.mozilla.com/techspeakers, whatever. You can read about how that program works and like getting involved there. So you might see myself and other folks with this like blue heart logo around at different events if you're at conferences or things like that. We are a friendly bunch. Please take a look. Anyway, those are just the obligatory information about some communities without which I would not be here, just because I think it's all about this community. So it's so exciting to see a community like this, just gaining momentum and getting funding and things like that. It's really amazing. So yeah, I would love to see your community intersect with some of these, if at all possible. Yeah, as I mentioned, I have a background that's not in computer science, but rather in the humanities. So I studied philosophy, actually, and linguistics and things like that as an undergrad. And so when I came to programming, I found myself really drawn to these like philosophical inquiries into like how programming works, and this notion of a programming paradigm really spoke to me as this kind of like high level, almost philosophical abstraction that comes up in the world of programming. And so I started getting curious when I started learning more about computer science. When I was at the Resource Center, I started doing a lot of reading and was trying to figure out like, where does this notion of a programming paradigm come from? And I found out that it was first kind of came to the public attention as a notion. The idea of a programming paradigm was first brought up by this guy, Robert Floyd, who won the Turing Award in 1978. And he, I guess when you win a Turing Award, you get to like start your article with a quote from the Oxford English Dictionary, which I always got in trouble for doing in college, but I guess everything's okay when you win a Turing Award. Anyway, he wrote this article where he gives this Turing Award lecture, which then turned into an article about the paradigms of programming as being these archetypes, exemplars, ideas, these almost like ethereal beings that we use to understand how programming works. And so this was really fascinating to me, and I started getting really curious about this idea, and I found that once I dug into it, it really helped me grow myself as a developer. So that's why I think it's a really interesting area for us all to spend a little bit of attention on. And this is what Floyd says, basically. He put this forward, and this is like decades ago, right? He said that I believe the best chance we have to improve the general practice of programming is to attend to our paradigms. And to think about the programming paradigm as like the unit of operation that we want to grow and nurture to have a better practice of programming. And I think we can all agree that programming is super frustrating and hard and sucks, and so we can always improve it. No, I don't think it sucks, but I do think that it can always get better. And so what does this mean, right, to attend to our paradigms? That was a question I was asking myself a lot, and again, having a bent towards the philosophical questions, I started asking myself like the epic, like what does it all mean? What even is a paradigm? And I realized that I had run into the notion of a paradigm earlier in my studies of philosophy, when in my philosophy of science course, we read this book called The Structure of Scientific Revolutions. Anybody read it or heard of it? I'm getting a couple hands, couple nods. I don't know if anybody Fairbanks or Gino has nodded. I hate you're so tiny. But in any case, this is a book written by a guy named Thomas Kuhn. Came out in the early 60s, where he's basically a historian of science, and he's trying to break down scientific progress throughout history and trying to understand like how it is that we as a community, as a civilization almost, are able to make scientific progress. And for him, it really turns around this notion of a paradigm. So he lays it out kind of like this, is that a paradigm is sort of a view of the world or an interpretation of the world and what it's made up of that gives us a way to understand that world. It's sort of like a lens through which we see the world, a worldview, if you will. Another way of thinking about that is kind of like it's a model of the world. It might be the universe, if like you're a physicist or a cosmologist. It might be that the world that matters is like, let's say, a human body, if you're a doctor or you're in the medical science. Or in our case, the world that we're interested in modeling is the computer. And the programs that run on it. And so you have in a paradigm a model of that world, of that universe, that allows you to make scientific progress in understanding that world and how it works. And if that paradigm is a model, then we immediately kind of get reminded of this quote. I don't know if folks have heard this quote from this statistician, George Box. He says, all models are wrong. And this is absolutely true of paradigms. Paradigms are not the actual world. They are just a representation of it, a model of it. And insofar as they are models, they are wrong. They are not a perfect fit for the actual world. So Kuhn describes this as leading to a kind of cycle of scientific progress that goes, that revolves around the theory, methods, and standards of a science, which are all contained in this notion of the paradigm, in the notion of the model that we have of the universe. And they're all inextricably mixed up in this paradigm, so that we get all three of these together, theory, methods, and standards, in the paradigm we're working in. Of course, me being myself, I'm always like, what does that mean? What is a theory? What are methods? And so Kuhn describes them as like a theory of what the universe contains. It's kind of like, what are the entities that the universe is composed of? How is it broken up into entities? And how do those entities behave and interact? That's like the theory of how the world works. But that goes hand in hand, he said, with these scientific methods and standards that essentially tell us like which problems we're trying to solve here when it comes to better understanding that theory, that world, and which solutions are good or legitimate responses to those problems or answers to those problems. So it sort of like tells us not only what the world is, but also what questions it makes sense to ask about the world, or which questions we should be asking, and what a good answer to those questions might look like. So this is all like very hand-wavy, kind of high-level philosophical stuff at this point, but one way we can kind of make that more concrete is to say that the paradigm, insofar as it contains not just the theory of how things work, but also tells us what methods we should take to understand it better, is what enables us to make scientific progress. And the way that that works, that progress, which is the thing that Kuhn is trying to understand in this inquiry, is that he says that, okay, in a world without a paradigm, what we've got is essentially no unified model that everyone can agree on as like a mental model of how things work and what questions we should be answering, what answers we should be looking for. And so everybody's off in their own kind of corners, like doing their own thing. Like one person is over here doing this type of experiment, trying to answer this question, another person's trying to answer a completely different question over there. Sort of like us all, you know, being at home with our computers, trying to like put 1 and 0 together, but doing it in completely different languages. We can't collaborate. We can't share knowledge. We can't really progress as a community until somehow the community coalesces around a particular paradigm. So one particular model of how things work and what questions we should be asking to understand how things work better. So for example, the one paradigm that emerged like out of the quote unquote dark ages of kind of astronomical or cosmological science was this geocentric model of the universe, right? Where we suddenly have the community agreeing like, okay, clearly the Earth is at the center of the universe, and all of the celestial bodies, the moon, the sun, the stars, they all revolve on these spheres around us because we are quite literally the center of everything. Of course, we're the most important. So this is now like a model of the universe that allows the community to make progress. Now people can start comparing their observations, they can start sharing notes, they can start asking to their questions about, okay, well, how does this work? How does that orbit happen, et cetera, et cetera. And so this allows for a certain bit of progress. But eventually, we run into this problem, the George Box problem, that this model is wrong. As we know today, this is incorrect. This is not how the universe works. The Earth is not at the center of it. And so what ends up happening, Kuhn says, is that this model, insofar as it is wrong, eventually gives rise to anomalies, to basically observations that don't fit with the model. So for example, like we observe, you know, Mercury going in retrograde, like moving in the opposite direction of what we would expect given all of the all of the celestial bodies are in spheres orbiting us as the Earth. And this is like a problem for the model. It's not easily explained by this paradigm, by this theory. And so what ends up happening is that people are very unwilling to let go of that model. They want to stick to their paradigm. So they find ways to like shoehorn the new anomalous observations into the existing model, right? Like by supposing, okay, well, sure, if we assume that all of the stars are going on these little epicycle orbits, like in their spheres, then we can explain how Mercury is going in retrograde. But eventually, Kuhn says, all these anomalies, they more and more crop up and they kind of accumulate, and eventually it becomes impossible to shoehorn them all in. And the scientific community enters this state of crisis where the model is kind of thrown into question. Some people are saying, no, we have to stick to this model forever. It is the one true answer. Other people are saying, no, that model is incorrect. Like, let's use this competing model. Let's use this new idea. But other people don't agree with that, and they're saying, no, let's use this other different new idea. And there's no progress being made at this point. Now it's basically like we're back at the dark ages. Everyone is arguing. Nobody can agree on what the model is, etc. And so we have a lack of progress until finally, out of the chaos of crisis, a new paradigm emerges, and we get what Kuhn is most famous for coining the term of paradigm shift. So we get this shift from the old, in this example, the old geocentric model of the universe, to finally somebody says, hey, what if we assumed that the Earth was not at the center of the universe, but that the sun was at the center of the universe, and that the Earth was on one of these spheres that's orbiting the sun? Then, in this case, all of the anomalies about Mercury going retrograde, etc., seem to disappear. Under the new model, they are accounted for. However, of course, this is also incorrect. Insofar as there's a model, it is still wrong, and so there will still be anomalies. And so what we get is this kind of this cycle that we're trapped in basically forever, to go from one wrong but better paradigm to some anomalies that we can't account for, to a state of crisis that forces us into a new paradigm via the process of paradigm shift, which then has its own anomalies and so on and so forth ad infinitum. And this is how scientific progress works, he says, that essentially it's a cycle of going from one incorrect model to another incorrect but slightly better model, so on and so forth. So, okay, this has been a lot of me blabbering about like the history and philosophy of science, and y'all are probably like, I thought we were at a developer alliance, you know, like what is going on? What does this have to do with programming? Well, again, being the philosophy student that I still am in some senses, when I was learning to program and learning more about computer science, I got really curious about this idea of the paradigm that we use when it comes to programming. And just like a paradigm in science tells us this theory of what the universe is and the methods and standards by which we can understand it better, we have paradigms in programming that give us answers to this question, like what even is programming? What is a program? What is a computer? How should we understand it? How should we think about our programs? And what questions should we be asking ourselves and asking our members of our communities to do programming better? And so that's where different programming paradigms provide essentially different answers to this question. Just like different models of the cosmological universe provide different answers to the question of what is the universe and what is it made up of. So we could sort of think of it, of the cycle of scientific progress here in programming, as starting out also in the dark ages, before we had computers. Back when computer meant like a physical human person who was doing computations with pen and paper and like a slide rule and like a logarithmic table and all of this stuff. And we weren't using machines to do this work for us until miraculously, somehow, we as humanity figured out how to like electrocute a pile of rocks and make it do whatever we tell it to do and make it think about stuff really hard for us. And lo and behold, we get computers. And in the early days, we get computers that operate in the imperative programming paradigm. So this being a paradigm that it conceives of a computer program as a sequence of commands, right? So imperative statements, like do this and then do that. So follow these commands, do them in the order that I'm telling you to do them. Like put this value in this address in memory and then move it over here and then add it with this other value and then print out the result, yada, yada, yada. And so this paradigm tells us that the universe of programming is made up of commands and they interact by being sequenced, and the order in which they're executed matters. And so that means that we have like time matters. We get these values changing over time. We get progress through our program over time being something meaningful. That means essentially that we have state. We have values changing over time. It's a stateful process. And this is like the worldview of imperative programming, right? So personally, I'm a really visual learner, and so I like to have like visual metaphors for things. What this reminds me of is something like a complex machine, like a clock, right? Where you've got, essentially the program is made up of all of these intricate little wheels that all do what they're supposed to do, but they have to do it in the right order. If things get a little bit out of whack, then the gears won't line up perfectly, and the whole thing will just grind to a halt. So you have to pay really, really close attention to exactly where every little tooth of every little wheel in this machine is. And you can think of this as being a type of anomaly, because as programs get more and more complex, thinking about the order in which the computer is going to be executing all of your commands becomes increasingly difficult, and managing that state, those changing values over time, becomes increasingly difficult. And the community of programmers found this to be a challenge, right? So it started to see state and this imperative model as a problem, having these anomalies of like, okay, this works great for if I'm just trying to add a couple numbers together, but as I'm trying to manage increasingly complex systems, it becomes hard to think about. So it gave rise to other paradigms. You could say it went through like a period of shift. One of the answers to this is sort of a sub-paradigm of imperative programming, which became known as object-oriented programming, where we're no longer so concerned with like the commands as the important entity that the universe is made up of, the universe of the program, but rather that we think of the program as made up of these little chunks of hidden state, which we're going to call objects. We think about the universe as being made up of those, and we think about them interacting by sending messages to each other, essentially by the mechanism of like method calls, right? So I'm gonna talk from one object to another by saying, you know, get this value. I don't see its value. I don't see its state. I can't read its memory directly. It manages that for me. It keeps that to itself, and it will send me back the correct response, whether that means calling its own method or calling a method of a parent that it inherited from or what have you. I don't need to know. All I need to know is what response it sends me back, what value it returns to me. So the metaphor, the like visual metaphor that I use for this comes from Alan Kay, so kind of thought of as like the father of this paradigm in many senses, who essentially gave rise to what became known as object-oriented programming in the late 70s, early 80s. Interesting fun fact about Alan Kay, he also did not have a background in computer science, but rather in biology, or additionally in biology. He was a biology major, and so he was very much informed by the biological metaphor of like cells in a body when he was thinking about the ideas that came to give rise to the paradigm of object-oriented programming. So the idea here is that now we think of the program not as being like a rigid collection of years and a rigid order of commands and things like that, but rather that we have a more flexible idea of a program where programs are essentially made up of mini programs that we're going to call objects. And those objects can also be made up of even minier programs, sort of the way tissues in a body are made up of cells, and those cells contain their own, whatever they need to do their job in life, all their little organelles and their little, I don't know, mitochondria and whatever else is in a cell, I don't know, and cellulose, but anyway, they contain all that in themselves, and they talk to each other by sending essentially chemical messages across their membranes, where one cell will emit a chemical that will be received by its neighbor cell if it has a receptor for that. If not, it'll just bounce off and the cell won't respond, won't do anything. And then once they've received that chemical, they will decide how to process it and what to do as a reaction. And the idea is that a biological kind of more flexible model like this can avoid some of those anomalies of imperative command-oriented programming by having more flexibility around when something goes wrong. Like if an individual cell dies, the whole tissue doesn't need to die. The rest of the cells can compensate for it somehow. Whereas if I have one misplaced go-to statement in my imperative program, that might crash my entire mainframe or what have you. So this is one way, one shift that emerged in response to the anomalies, you could say, that the community found with imperative programming. Another one would be the paradigm of functional programming. I don't know if anybody who's like got into functional programming, I see a little nodding, but this is another one that found that state, that changing state, the mutable state of imperative programming to be anomalous, dangerous, you might say, because it can lead to programs, it can lead to bugs, it can lead to difficulty in like thinking about code, which is, as programmers, like our day-to-day. And so it decided to create another answer to this anomaly, another shift, another direction for the shift, in which we think about the program as being composed of pure functions. A pure function being something that takes some data in, looks only at that data, does whatever computation it needs to do, and returns some value out, and does nothing else in the world, like touches nothing else, changes no state anywhere. There isn't even state to be changed if we have a program entirely composed of functions like this. So we really think about these, about the overall program as being composed of these mini programs, which are data coming in, some computation, data going out, and those being chained up together in a way that creates the bigger functionality that we're looking to perform. So like the visual metaphor that I think makes sense for that is something like an assembly line, where basically you've got kind of like raw materials coming in, you have one station on the assembly line that processes that into like pieces of a car body, and then you have another station that takes in the pieces of a car body. It doesn't care about the raw materials, it doesn't care about anything that happens later, takes those pieces, assembles them into the body of the car, and so on and so forth. You have the tires put on, you get et cetera, et cetera. But each of these is only looking at its input values and only concerned with outputting its return values. So the idea here is that now we're thinking about programs not in this biological way, but in like a pipelining way. So we're no longer thinking about tissues and cells and that type of metaphor, but rather we're thinking about how can we flow data through our programs and how can we represent the problems that we're trying to solve as data transformation problems. So this is one worldview we could have, and this is kind of like a subset, I guess you could say, of the declarative programming paradigm, which is sort of like an umbrella paradigm, in which is often considered as sort of the yin to the yang of imperative programming, where if imperative programming is all about commands, and I'm saying do this and then do that, and I'm telling you exactly how to execute what I want you to do. Declarative programming is more concerned with making, instead of these imperative, like do this statements, it's making declarative, like this is the case statements, where I'd say things like, these are the facts I know about the world, this is what I want the output of this program to look like, and then I let the computer figure out how to do that. So we're no longer specifying like first do this and then do that. We're just saying, look, this is what I want, just give it to me, I don't care how. So this is something like SQL, for example, is kind of the archetypal declarative language, where we're not telling it like how to perform the join or whatever it needs to do. We're just saying, look, I just want this data out of my, out of this table. I don't care like what order you retrieve things in. I just want you to give me an output according to this specification that I've given you, this declarative specification. This is what I want. So the visual metaphor that I like for this is it's kind of like a Sudoku puzzle. Does anybody play Sudoku? It's like number game. Okay, cool. So it's like, you know, it's a logic puzzle basically, which also evokes the sub-paradigm of declarative programming, which would be logic programming, things like Prolog and whatnot, where essentially, like if you're the computer in this metaphor, you're given this specification of like, these are the facts about the world. There's a 1 in the top left corner and a 6 in the top right corner and so on and so forth. And what I want is a grid where every row and every column and every box has the digits 1 through 9. And I don't care what order you fill out this grid in. I don't care if you use pencil or pen. I don't care if you like write in your guesses and then erase them. I don't care if you go top to bottom, left to right, or if you do it in sporadic order. It doesn't matter. Just give me that completed grid. So the idea being that it's no longer about how, it's about what. So in any case, this is just like a small fraction of the potential ways we could think about what a program is made up of and what it makes sense to think about when we're writing programs or when we're trying to understand programs. Does it make sense to look at the commands and the order that they're executed in? Does it make sense to think about the data that's flowing through and how it's being transformed? This is just like one small sampling of a bajillion different ways we could look at this. And there's somebody who's even more excited about programming paradigms than I am, named Peter Van Rooij, who is a computer scientist in Belgium, I believe, who has done a ton of has thought a lot about programming paradigms and how they relate. This is, according to him, just the principal programming paradigms. As you can see, there's a lot of boxes. You don't need to read them all. But essentially, the idea is that there are probably more paradigms than we can count, and they this is just a sampling of them, and the 4 that I mentioned are just a small, tiny taster of this principal set. And the idea that he says that paradigms are basically collections of concepts that that certain paradigms we can talk about a paradigm supporting concepts, and then we can talk about languages as supporting these paradigms insofar as they support the concepts that they're made up of. So, for example, we might have the concept of procedures as being central to different paradigms, including imperative and functional programming. But we might think about state as being a concept that imperative programming supports, but functional programming does not. And so on and so forth with various other concepts broken down here. We're not going to go into detail of all of them, but ideas of threading or of determinism or all these different concepts that essentially we can think of paradigms as being collections or little like chunks of different concepts wrapped up in a nice little bow. And that some of these, what I think is really interesting about his work on this and the way he's broken this down into this chart, and all the references are in the slides at the end, by the way, if you want to dig into this later, but is that certain paradigms that we think of as being like diametrical opposites might be separated by just one concept. Like there might be just one little switch that you can flip that takes something from functional to imperative programming, or from functional to object-oriented programming as a subset of imperative programming, let's say. And so what this raises in my mind is the question, like, these paradigms, I've been thinking of them, or I've been talking about them, or perhaps we as a community have been thinking and talking about them as though they're like completely different ways of doing programming. And people get into these insane arguments on Reddit or Hacker News or whatever, where it's like, oh, functional is the one true king of programming. It's like, no, like Haskell is lame, I don't like Haskell, I'm gonna do Java forever. Oh, that's stupid, Java's stupid, like, People get into these epic battles over these paradigms and the languages that to support them. And when I was first getting into programming, I would read this stuff and be like, oh gosh, I might use the wrong paradigm and not be a cool kid. And as I started to read more about them and learn more about them, it became apparent that they're so close in so many cases that sometimes we're arguing about like 2 different facets of the same coin, or really we're more in sync with each other when it comes to the questions of what is the program and what should we care about when doing programming than we might think given the Reddit threads or the Hacker News threads or what have you. So I think that functional programming and object-oriented programming is a great example because these are often seen as like epic rivals of programming paradigms, but like, are they really so different? So if we think about both of those paradigms as being one type of solution to the anomaly, as it were, of shared mutable state, which was a problem for imperative programming because as programs become more and more complex, and you have to remember like what value is in what memory address and how that was changed by this part of the program and how this other part of the program expected it not to be changed, but it has to account for the possibility that it could have been changed because it doesn't know whether it's being executed here or here, and blah, blah. This becomes really difficult to reason about. So these two paradigms, functional and object-oriented programming, both wanted to solve this problem. They're like, okay, shared mutable state is an anomaly. It's a problem for programming. We need to get rid of it. We need to have a model that doesn't have this anomaly, that accounts for a better way of doing programming. The only difference between them really is like how they chose to account for this anomaly. So functional programming was like, well, hey, how about we just forget the entire idea of mutable state? How about we just never change values over time? And once we've set a value, it's immutable. It's staying there forever. And if you want a slightly different value, a slightly different object or what have you, you have to like create a copy of it. You have to process it in a new way so that I can never mess up the value that my coworker thinks she's working with. I can only create a new version that I'm going to work with. So they say, okay, once we get rid of mutable state, then we can share stuff as much as we want. We can pass values back and forth between functions. It doesn't matter who sees the value because nobody can change it. So this is where like functional languages like Haskell or Erlang, like once you declare, x is equal to 5, that's it. Like x is gonna be 5 forever. If you want a new thing, it's gonna have to be x prime or y or whatever you want to name it. This is one way that we could account for that is by thinking about now things have become transformations of data and we no longer have mutable state and we can share as much as we want. The way object-oriented programming chose to solve this anomaly was the other direction. It's like, well, mutable state wouldn't be so bad if it was never shared. Like, if only I can access my private values, if they're safe behind my cell membrane, then you can't come in and like mess with some number that I thought was going to be 5 that you think should be 6. Like, no, you can create your own cell, your own version of that state, but if you want to read my value, that's controlled by me. You don't get to touch that. That's private to me. So again, the solution or the problem that they're trying to solve is the same. It's just a slightly different solution. And what I think is interesting is that both of these solutions really end up looking more similar once we dig into what I had as like a misconception about object-oriented programming. Alan Kay actually anticipated or answered a long time ago. So this idea that objects are somehow the central notion of object-oriented programming, which one could be forgiven for thinking, given the name. Alan Kay says that was an oops, that was a bad idea. He said, I'm sorry that I long ago coined the term objects for this topic, what became known as object-oriented programming, because it gets many people to focus on the lesser idea. The big idea is messaging. He says the big idea is this idea of these chemical, the metaphor of the chemical molecules being passed back and forth. In object-oriented programming, messages or the way that we communicate with objects, the way that we ask them for values, the way that we ask them to set their values, etc., is all by sending them messages via method calls with inputs, potentially. So that when I make a method call on an object, I'm saying, hey, I would like you to please set the value for your private hidden variable to 5. But I'm going to let you figure out like what that means you need to do. And then you can tell me like, confirmed, I changed the value to 5, or rejected, I'm not doing that. The value is 6 and it will always stay 6. But essentially, we can think of it as like we make these calls and we receive return values as sort of like responses. And that to me sounds very similar to like in a functional way of doing things. We're giving input variables, we're passing in arguments, we're passing in values to a function, and then we're expecting return value as the output. And so both of these are really representing programs as being composed of chunks, sort of sub-program chunks that are defined not in terms of the data that they contain, but in terms of their behavior. How do they behave? How does a function behave when I give it certain inputs? What's the return value? How does an object behave when I call this method with these inputs? What does it do? How does it change its private state? So these two paradigms, they seem really different at first glance, but under the hood, we can see a similarity where they're both conceiving of the program as what's important in the program is its behavior. And so what's really interesting is that if you look at the languages of the lambda calculus, which is kind of like the archetypal functional language, it's, you know, the lambda is the logo of like every functional language ever, like Haskell and Clojure and whatnot. And Smalltalk, which is like the archetypal object-oriented language developed by Alan Kay and others in the 80s, they both define Booleans in terms of how they behave essentially as choosers. So like a Boolean in the lambda calculus is something that takes essentially like an if clause and an else clause, and if it's a true value, it'll do the if clause, and if it's a false value, it'll do the else clause. So it essentially chooses which path to go down in a control flow scenario. And the same is true in Smalltalk, where essentially something is true if it chooses the first of two values, and something is false if it chooses the second of two values. The syntax is different, but the idea here is the same, and the details of this don't matter. The point is that in both of these languages, we're representing the concept of a Boolean as like, how does it behave when given certain inputs? So I don't know about you, but this was like, what, when I first read this? Because again, it's like these epic rivalries that we think exist in the world of programming paradigms aren't necessarily there if we start to look under the surface. It might be that there's just one concept, in this case, state, that separates the two paradigms. So it's like, can't we all just get along? So instead of asking this question, like which paradigm is the best, like which language should we all be learning, or which paradigm is like the cool one, we should rather be asking ourselves, what is a paradigm good for? So returning to our George Box quote from before, he said all models are wrong, but he doesn't stop there. He says all models are wrong, but some are useful. So we should be asking ourselves not, is this model correct, but what is this model useful for, if anything? And that's like really visible in the physics paradigm shift that happened from Newtonian mechanics to like relativity. And Einstein comes up and shows us all that like Newton was wrong this whole time. And then once you get stuff going really, really fast, the laws of Newtonian mechanics break down. However, that doesn't mean that Newtonian mechanics isn't super useful for doing stuff like building bridges or predicting what's going to happen when like billiard balls collide or whatnot. Newtonian mechanics is still something that we use all the time, every day in our daily lives. It's still a very useful model, even if it breaks down in certain scenarios. For big, heavy, slow things, it's great. It's just not great for trains going the speed of light or whatever. So when we ask ourselves about these models, and in our case about programming paradigms, we want to be asking ourselves, like, what does the model illuminate? What is it good for? And so this is what I would just like encourage all of us to do, is to ask ourselves not like, is this language good? Or is this paradigm good? But like, what can I learn from this language? Or what can my program benefit from by using this paradigm? And so that's where the question of like what a paradigm can illuminate highlights the idea that we can do our best work as a community and as individuals by flipping back and forth between paradigms as we need to based on the problem that we're trying to solve. I think we're getting short on time, so I'll try and accelerate here a little bit. But if imperative programming is really concerned with like explicit instructions, like do this and then do that, what it can kind of illuminate for us is to focus on those explicit instructions, to focus on the implementation, on the how something happens. And since our computers are kind of, we could think of them as kind of like stuck in this paradigm, like the computer is still always like executing instructions one by one in the order that we give it to them. If we learn to think like the computer thinks, then we can hopefully be more machine efficient by talking to it in a language it can understand, as it were, a language of commands, of imperative commands. So for example, it might be really useful if I'm working in a functional language like Elixir, anybody used or heard of Elixir? A couple hands. So Elixir is a functional language based on the Beam, which is the virtual machine of Erlang, which is another kind of functional language. In any case, it's a language that's gaining a lot of popularity. There's a cool like web framework in it, and so people are all excited about Elixir because doing functional programming can have a lot of advantages for the high level. However, occasionally you need some really, really performance critical code. Functional programming might not be that great for it. Imperative programming might be what you need to get really on that like low machine level. And so Elixir, like many languages, exposes this idea of like a foreign function interface, or in this case, it's called a native implemented function, I believe, NIF, which is funny. And so you can have a NIF, you can have a function essentially that's written in some other language. In this case, maybe an imperative language like Rust, that allows you to get real low level, like really do the performance critical imperative stuff you need to do, whatever complicated math and calculations and whatnot, but wrap that up in a way that exposes a functional interface to your functional language, in this case, Elixir. So you can kind of drop down to that lower level when you need to, and drop back up to the high level data transformation paradigm of in this case, functional programming, when you don't need to get that low level. Sorry?
Yay, assembler.
Right, a similar idea with like if folks have seen things like dropping down to like WASM compiled functions that were written in C or Rust in a JavaScript program, for example, similar idea. Okay, on the other side of the coin, we've got the declarative paradigm, which teaches us to be really abstract, to focus on like super high level, like whatever makes most sense for the domain that we're trying to model, and to really operate on the level of like human efficiency, like domain expert efficiency rather than machine efficiency. So this might be something that we do when we pop out of a language like, let's say, an object-oriented language like Java, well, arguably object-oriented, definitely imperative, and we want to have like a higher level way to just declare, like, let's say I want events on a calendar. I want there to be an event with this name and this date and this location. And I can implement essentially a domain-specific language that's, in this case, called an embedded DSL, an embedded domain-specific language, because it uses a subset of the syntax of the host language, in this case, Java. I can write that implementation however I want and have the user be able to program in this super high-level declarative way without caring about what the implementation details are, so that the user can focus on the domain. This is really useful when we're trying to write like languages to allow domain experts to interact with the computer without needing programming knowledge per se. DSLs are super handy for that. This is from the book by Martin Fowler and Rebecca Parsons that goes into everything you could possibly hope to think about a DSL. Object-oriented programming, then, with this notion of like cells and membranes, it sort of focuses and illuminates what the power of encapsulating things and remembering values and kind of keeping that state hidden, which can be useful when we find that writing in, let's say, a functional style in a language like F#, which is one of these multi-paradigm languages that lets us, it's kind of functional first, like it lends itself to functional programming, but you can also do object-oriented programming in it. You might find yourself writing a functional API where you keep having to pass in the same set of dependencies over and over again. And if you're doing it in a pure functional way, anything that the computation depends on has to be passed in as an input to the function. So that means you end up with these increasingly exploding like function signatures, which can get very laborious over time. So it might be useful to take all of that common stuff, wrap it up in an object, and write a more object-oriented API where you have the API kind of is this like instantiation that takes in all those dependencies once and then gives you methods that just take in the various arguments you want to do particular things with, and all of those methods have access to the dependencies that you've remembered using this kind of object-y wrapper. You can do the same thing in functional programming using the concept of closures, essentially functions that like remember the context in which they were defined. But the idea is that that notion is kind of what object-oriented programming can illuminate for us. At least that's how I see it. This is from an article by don't quote me on the first name, about using object-oriented programming in a functional language like F#. And then, as I said before, what functional programming itself can illuminate for us is like thinking about the program as a process of data transformation and really isolating each part of that transformation like a little station on the assembly line. And so there's a great article and a corresponding talk by Jessica Kerr, where she talks about, she's working in an object-oriented language, I want to say Java, I'm not sure, and she's trying to diagram out this problem, this program that her team is going to need to work on, and she's going to need to give to her team, or like 3 or 4 different individuals, to all like go out and work on their individual parts with. And she's working in this object-oriented mindset where she's thinking about like this kind of imperative, like, okay, we're gonna first need to do this and then do that, but like this belongs to this other, this belongs to this part and this belongs to that part, so it's gonna need to talk, we're gonna have dependencies between these types of objects, and she ends up in this like gnarly, like cyclical, very difficult to think about diagram that's not only difficult to think about, but also difficult to see how you would divvy this work up to give to your team to allow them to all go off and like do their work and put the pieces back together, because all of the parts are kind of dependent on each other. She says that when she switched her thinking to like this functional data processing model, that she was able to reframe the problem as like, okay, this is my source data, these are my inputs, this is the output that I want, these are the ways I'm gonna have to transform it and merge it together and maybe split it apart and whatnot in order to get from point A to point B. And what she ended up with is this diagram that's like much cleaner, much easier to think about, and much easier to chop up into chunks that then individual people on the team can go work on and only concern themselves with like their inputs and their outputs, and then all of those pieces can be chained together in that assembly line later. So what she's saying is that like even if you're working in an object-oriented language, thinking about the problem in a functional way can sometimes be a game changer in terms of what it can illuminate for you and what difficult things it can kind of make just magically disappear. Okay, in any case, to sort of wrap this up, because we're over time, as Peter Van Roy, the guy who made that big chart of all the different paradigms, puts it, each paradigm supports a set of concepts. That those concepts make that paradigm the best for a certain type of problem. Concepts are ways of solving problems, and paradigms are just collections of those. So again, the question is like, not is this paradigm good, but is this paradigm good for my case, for my problem? And the idea that that Peter Van Roy espouses is that languages which support many paradigms are really useful because they allow you to seamlessly switch back and forth as the problem calls for without changing syntax, without changing tooling, without changing your development environment. And so working in multi-paradigm languages is a really great way to be able to choose the best paradigm for a given problem. My point in saying all of this is that like paradigms are, in my view, what allow us to do good, like do any programming work, let alone good programming work as a community, because they kind of define like what that even means, like what a program is, what the act of programming entails, and that's what we all do or want to do, hopefully, most of the time. And so as we are working in a particular paradigm, it's important that we recognize what it's good at and like embrace that and let it be good at the things it's good at solving, and not try to shoehorn those anomalies like into it, not try to force an object-oriented language to be really great at like transforming data in a pipeline. No, like let's switch over to a functional paradigm if we need to do that. And that's the idea of like, we want to be open to shifting, not just like as a community, but within ourselves. And so I found that once I started building fluency with a few different paradigms, I was really able to like get a lot more out of programming and have a lot more success as like writing code became less frustrating when I was able to switch into the more appropriate paradigm for a given problem. So returning to this dude Floyd, who gave that Turing Award lecture about paradigms and kind of coined the term and like brought it to our attention as a community, he says that if the advancement of the general art of programming requires the continuing invention and elaboration of paradigms, basically like elaborating that chart that Peter Van Looy was working on and coming up with new paradigms as a community, coming up with new ways of thinking about programming. Then advancement of the art of the individual programmer requires that they expand their repertoire of paradigms, meaning that as an individual, it behooves me to learn as many different paradigms as possible so that I have the tools, all the tools in my toolbox to choose the right hammer for the right nail. And that as a community, we need to like build new hammers that can hit different nails better. And we need both of these to really like advance programming. He didn't say it exactly like that. He was a little confused about how singular pronouns work in English and gender roles and whatnot, but I fixed it for him. It's okay. He's just a Turing Award winner. He's not that smart. We can't expect that. Anyway, so the idea is that, like, I really hope that communities like this are amazing because I think it's a great way for us to like exchange knowledge, go away, learn new paradigms, learn whatever functional stuff or imperative things, whatever it is that we're lacking in our toolbox, and also to like come up with new ideas by talking to each other, by discussing the anomalies that we're having when we're trying to solve the problems that we're working on, and to really like hopefully push the whole community forward. So yeah, just basically like let's take a moment, let's take a step back and make sure that we're attending to our paradigms like Floyd told us to do in 1978, and we're still working on a few years later. So yeah, that's basically all I wanted to say. Thanks for the time, and thanks so much for having me here. I'm so excited to be here with all of you. I look forward to hearing about all of the paradigms that you all work in and languages maybe you're learning and things like that. So hoping we can chat for a bit after the event. But yeah, huge thank you to some of my batchmates at the Recurve Center who helped me understand some of these concepts and really like open my eyes to this whole world of paradigms. And huge thanks to Jeff for bringing me up here, and to you all for coming out, and like so exciting to see the momentum building around this community. I really look forward to seeing where it goes next. Thanks so much.
So if we want to take a moment, if anybody wants to ask questions, now's a good time. I just want to start it off with a comment, which is that I think one of my eye-opening moments as a programmer was switching from learning Java and computer science and PHP and C# to first time I played around with Ruby, and it was completely dynamic. You can sort of do whatever you want. You could do declarative programming. You could make functions. You could make objects. But it wasn't until like several years later where I actually read a book on like messaging. Right, I was like already 10 years in, and I'd been practicing programming and making money doing it before I understood the concept of messaging. And when I started to read this book, it really occurred to me just how often like most of our code is actually like fluid between all these paradigms, and we just don't even realize it. Like it's really common to have a script that you write just to hack something together in a second, and have like a mix of functional, declarative, and object-oriented in the same code. So this is really cool to see this broken down into all the different theories.
Well, yeah, I mean, I absolutely have a very similar experience because I've been writing like object-oriented Python for a long time before I realized that like that's not what object-oriented, classes and like different types of vehicles and like how many wheels they have and whatever. It's like not the main idea. that it's really more about like how these elements are communicating and whatnot. And so I had a similar experience of like realizing, wow, I have been thinking about this in a really like difficult way when it sort of made everything more clear when I started reading all this stuff now. Okay. At the same time, it's like, if we find ourselves, for example, flip-flopping between these paradigms, perhaps that means that there's like another third paradigm that we should be using, that we're not using, that we haven't thought about. So yeah. I think like just thinking about it on that level has been really useful. So, yeah.
Just another shout out for anybody who's on the live stream right now. Feel free to shoot me a message on Slack or something, and if we can't hear you, I'll get you ask up. So also, I know Eric Talby in Fairbanks is really curious to get a copy of your book list. So
yeah, maybe
we can send that out.
Yeah, and these slides are actually already up on my speaker deck, or like a previous version of these slides with the same references. It's up on I think it's speakerdeck.com/PLA. Should have all of my stuff. You'll be able to find it. It's the one that says programming across.
I'll make sure we get
In any case, we'll share the link, yeah, afterwards, for sure.
You didn't say this explicitly, but I'm certainly getting the impression that holy wars result from people misunderstanding the principle that the tool should be suited to the problem. Do you agree?
I think, yeah, I think, when people get more concerned with like the,
Their
the-
language.
sorry?
I've run into that, just in various workplaces, like, well, we're not gonna write in that language because we don't do that.
Hmm. And I think there are legitimate reasons to not use a particular language, right? If you say like, we don't write in Rust here because we have a lot of problems that are better adapted to like a higher level language, fine, fair. But that's different than saying like, Rust sucks, like we shouldn't use Rust, And I think that when people start attacking the paradigm or the language and saying that it's bad, like I don't know if folks like read these quotes from Dijkstra where he basically just like rags on every language up until the point where he's writing a thing, he's like, that was a mistake, and that is mentally like going to mess you up and you'll never be able to think straight again, and this other language is terrible, and this other language is like an infantile disorder, and well, says all this really horrible stuff about like, it's in a different talk, it's in that language, so I can share those slides later. But anyway, like that kind of stuff, I don't see that it doesn't add anything. It doesn't illuminate any reasons why we could be better served by some other solution. All it does is like waste time, in my opinion, waste time on like nitpicking over syntax or over like, I don't like this language because its tooling is worse or what have you. Like that doesn't actually help us get better as programmers, as a community or as individuals. So I think that the holy wars a lot of the time have less to do with like the actual practice of programming and more to do with these social things, these gatekeeping, this
Another paradigm, sorry.
This idea that like, you can only be a real programmer if X, Y, Z. And that I think is like actually long-term does huge damage to the discipline and like the practice, the work that we're all trying to do here is like in my opinion, it's like write better systems using better languages or paradigms or whatever tools we come up with. And if we're just, shitting on each other about it all the time, then we're not gonna be building anything better, just wasting time on Reddit, essentially. So that's my personal 2 cents on the matter.
Go on Reddit other than waste time.
I'm not personally a user, so I don't know. But in any case, it's like, I've seen some good. There are some that are actually like
Productive.
aimed at inquiry and understanding.
r/AWW.
I think one of the places that I really started to see this was like when I started traveling and going to conferences and taking courses again. It was really amazing to me. So when I went to that course, the first question that was asked was like, who here is like from Miami? Of course, nobody there was from that area. Then the next question was like, how many people work solo? And like 75% of the room's hands went up. And then the next question was like, what languages did everybody use? And it was PHP, Ruby, and Python. And so everybody there was learning a statically typed language. And that, I think, was the first time that most of these people who had been so focused on productivity had actually had a chance to take a step back and focus on a new paradigm, but then also focus on more of a performance and at a computer science perspective to that sort of productivity. And what was really interesting about this was just seeing the light bulbs go off with everybody in the room and how they're seeing, oh, statically typed languages, right? They're great for what they do in the computers, but like, what are the benefits of a statically typed language among, say, 5 programmers who are trying to collaborate? And that, to me, was what really started to illuminate this underlying understanding of what paradigms were. And so, now for me, one of the most frustrating things that I deal with, going back to Ruby, is realizing that like 80% of my tests revolve around checking for nil. You don't know ahead of time what the value of the variable is going to be.
So that was like a huge game changer for me. It was actually taking that time to learn a new paradigm and understand what some of the benefits of that paradigm can be. And that's not just a shout out for Go. I still read a lot of reading.
Yeah. Yeah.
How do you know to like you don't know what you don't know. Like if you didn't know that like that statically typed languages were bad at these things, you wouldn't know to like look for alternatives. And so like the people that thought the Earth was the center of the universe, like they don't know that Jupiter has moons. And so like how do they know to like ask questions? How do they know to like advance anything versus like using old paradigms?
Yeah, well, I think, I mean, I can't speak for Thomas Kuhn, but my answer to that would be like that essentially, one thing we can always know is that there's something that we don't know. We can always be cognizant of the idea that there is a better solution out there than the one that I currently have, that there's something that I am not aware of in this world that doesn't fit with this solution. And so one thing we can do is like keep that open-mindedness so that we can perhaps more easily recognize those kind of anomalous things. And sometimes if we convince ourselves that like this is the one true answer, or like Haskell is the one true programming god or whatever, we can be kind of like, you know, you sort of only see what you want to see. We can sort of be blind to those other things that might not fit so well, or that might give us motivation to shift our thinking. So that's one thing I think we can always do is like keep ourselves open to the possibility or the certainty that there is a better answer out there. I think another thing is like that it's inevitable that there will be a time, like a delay between the first of those like weird little difficulties trickling in and the point where like they've built up so many and so long that you can no longer tolerate life in the old paradigm, the old system. So that like, for example, one little weird like blip across the sky, you're like, huh, that was strange. I don't know what that was, but it's probably not a big deal. Like, this test is intermittently failing. I'm not entirely sure why, but it's passing in PI right now, so I'm just gonna merge and hope for the best. You know, that sort of thing, right? There's going to be that kind of time where like it's not worth it to completely change the way you're thinking about programming, the tooling you're using, the conferences you're going to, the whatever it is, until you found that like maybe it's not that this one test failed, it's that I honestly can't find a way to create reliable, trustworthy tests for my system under this. Let's say I'm writing imperative code or object-oriented code. I'm jumping through so many hoops in my testing framework and in my fixtures and everything that it's just like ruining my week. That might be then motivation to say, oh, I wonder if there's like a way to have more reliable tests. And in this very like randomly chosen example, you might find like, oh, well, if I'm using functional programming, then all I need to do is pass in certain inputs and check if the output is what I expect. I don't have any state to mock. I don't have any really like integration tests aren't even really needed because I know that if this output matches that input, then like I can change them all together, for example. So I think the idea is like knowing when that accumulation has really come to like the breaking point of I'm spending so much time wrestling with these anomalies that I can't get any of my work done, or the trade-off is not ideal. I think where that is different for everybody. It's different for every team, for every project. For example, I'm much more likely to like shoehorn stuff in if I'm just doing some little personal project. I'm not likely to like go off and try to learn an entire new language than if perhaps, you know, a team at my company recently switched languages for one project because they found that there was such a steep learning curve for this one language, given its history and its context, that they were spending a lot of time just trying to keep people up to speed, when if they switched to this other language, they found that there was a little bit of a learning curve, but then it really plateaued and they were able to accelerate much faster. For example, so I think where that trade-off is, like where that tipping point is a totally kind of case-by-case thing. And I think all we can do is like watch out for it and remember that it's gonna come eventually. I don't know, that's how I see it. I don't know if folks have other thoughts.
In that trade-off, do you think larger companies have an inherent advantage because they have the time and money to spend on educating their developers for these branches? Because I found that at smaller companies, I might be working on a 40-year-old simulation and it's terrible, but no one has time to change the whole thing or rewrite the whole thing. And furthermore, there's so much old domain knowledge in there. Sometimes the scientists forget that they don't feel comfortable changing it.
Mhm.
And they're unwilling to move it out of Fortran because they lose 30 years of domain knowledge. And so I'm curious what you think about that. I mean, from like a scientific software perspective, it runs with a lot of really old software, and no one's ever had time to really refactor it or do a paradigm shift. Whereas I imagine like if you're working for, I don't know, Google's quantum computing department, they're willing to spend a lot of money on you to rewrite it. They have more time in that sense. So,
No,
Sorry, there was a comments from Fairbanks. Somebody said Boy Scout rules leave the code better than you found it.
because I mean, I don't know, like you heard the lava flow development,
sorry, what flow?
the lava flow anti-pattern,
I haven't.
where the
What
code's
is that?
continually just sort of crusting over and slowly building up into this massive blob. It's just
Awesome.
yeah. Or like it's like the blob anti-pattern.
Okay, yeah. No, I mean, I don't know the term, but
Yeah.
I feel your pain. I think we've all been there one way or another, where like you feel that the inertia of a project is like too strong, whether that be because there's some higher up at the company saying like we will never change this, or whether it just be like you don't have the time to rewrite, to port everything to this new language that you know would solve some of these problems. I don't know that it necessarily that always a bigger company is better able to respond and switch and shift paradigms, as it were. I think sometimes it can work to your disadvantage. For example, if you have a big company with a ton of tooling, a ton of like say like internal development, onboarding and stuff like that, that could be red tape, licensing, all these considerations can be like, as a company gets really massive and has been committed to a particular paradigm, software, whatever it is, platform, that can be like a huge factor against or that prevents shifting when you need to. On the other hand, I totally hear what you're saying, that like if it's just one person trying to keep a whole bunch of systems afloat, they're going to be focused on like duct taping leaks in the dam rather than like rebuilding the entire thing. I think that ideally, we create organizations, whether that be companies or communities or whatever it is, that are able to divide work and retain autonomy over their work in such a way that they're able to remain not like that they're not only beholden to the let's say the business implications or the short term like revenue that's coming in, let's say, that they actually have built into their roadmaps time to periodically review tooling, review language choices, to take those steps back. So ideally, like I see the ideal situation as being like small groups that are able to pace their work out in a way that factors in that expectation that like there's always going to be a better solution. We're always going to be wrong about the choice that we made about this tooling or this software or this language or what have you a year ago or 10 years ago, and factor that into their planning so that they have built in like time to dedicate to that higher level, that like kind of step back, like are we even using the right hammer here? I think that there can be like, maybe there's like an ideal medium size of company where that's easiest. I've seen it be difficult at all sizes of companies.
It's a
personally.
problem.
Yeah.
I was gonna say, in my experience, it's not any easier as big companies. It's actually a lot of times harder because it's also, let's say you want to move from Java to Rust. Now I have to retrain all of my development staff to learn Rust. That is a huge cost and a huge risk that a business is probably not. I don't care if Java is less efficient if I don't have to worry about it breaking everything in the process. But I've also been at a small company where you're the only guy doing it and don't really touch anything. Because I've been working on it.
I would agree with that. Google is probably different than most development shops anyways, but I would agree.
Well, I would say even at the bigger shops I've ever seen or worked with, so I've done a lot of consulting, there's always somebody willing to back innovation. You just have to make sure there's a business case for why you're going to do it, because Rust is a better language isn't an answer. Because that doesn't really tell me what I'm going to get from a business perspective that's going to justify X, Y, or Z cost. You know, if you can say, look, we do this, we're going to reduce overhead by X, we're going to be able to get you new code out faster, things like that. Put it in a business context. There's always somebody willing to back you because it makes them. It reduces their overhead, it reduces their costs, and it makes them get promotions.
I think a lot of this overlaps with another piece, which is that it's really difficult oftentimes to measure when you're trying to accomplish sort of these paradigm shifts when you're changing technologies, right? So I was recently talking with a company down in San Francisco called Pantheon. They're a VC-backed sort of like WordPress Docker container deployment company, but they allow companies to deploy marketing websites, but also include like A/B testing and fault tolerance and like all sorts of cool stuff. And when I was talking to their CTO, one of the things that they really try to bring out was that they optimize for developer velocity within their organization, as opposed to, say, performance, right? So where I've run into that, this like personally is in building my own products. It's like, well, you know, right now what's really important to the projects that I'm working on are my ability to iterate and to hop into the console of Rails and like play around with the data and look and find anomalies and problems that my customers are running into versus having the most, say, performance system, right? Like, does it currently matter that a web request takes 200 milliseconds, or does the fact that I can go back in, find the issue, fix the data structure, and get all of that data re-rendered and reprocessed for the client, is that the benefit there? And so I think one of the pieces we run into is sometimes we, as the technologist, the person who is working on the problem, look at the way things have been done. And there's two things. One is that I heard this great quote, which is that there are no bad developers, just developers in bad circumstances. And I think that says a lot, right? So I mean, think 30 years ago when somebody is writing a scripted Fortran that's doing scientific modeling, it's like the model could be wrong, Fortran could be wrong, the computers could be wrong. They may not have had their own computer and they had to ship the code off somewhere. So when we think about a lot of these either legacy systems or the problems we're currently looking at, is it a matter of the technology and the code, or is it the business case, or is it, you know, the case of like, what are we optimizing for? Is it performance? Is it developer speed? Is it, you know, like money, right? Like how many servers is this running on? In that case, it might make sense that there's an overlap between performance and CPU optimization. More likely than not, it's probably RAM. So I think that's one of the other pieces that thinking in many different paradigms brings to light, is that, you know, just as often as we need to think in different paradigms for what types of data we're dealing with and what we're choosing to use as a language, we also need to be thinking about like what problem are we currently optimizing.
That's actually really good. When I was working at my last job, just to give a concrete example of that, there was a team of 2 people that spent 6 months to make the program run 30 minutes faster. It took 8 hours to run and it ran once a day. What value did that deliver to actually make it run 30 minutes faster? It was already well under the time. So, you know, not keeping focused on what problem you're actually trying to solve. They solved the wrong type of problem.
And this ties back to the answer to your question, which was, you know, how do you know when to do a paradigm shift? If, you know, at the largest case. And I think as you get a little more experience, even if you're a solo developer or you're working in a larger organization, is learning how to build in enough slack in your timeline so that you can do that creative exploration that's required, because otherwise you're not going to get the chance to make a business case.
Yeah.
You've got to protect your own self, your own ecosystem, you know, your own oikos here to say, well, I've got this harebrained idea and I need just a little bit of time to go run that. Let's go run that.
But maybe take half a day to figure out, is it gonna work?
Right, or you have a cancellation, like, okay, I'm gonna go try that thing, because you've got to satisfy your own curiosity, but then also you will come up with all kinds of new ideas that will have a business case.
And you just kind of throw back to what you were saying earlier about when do you know? I mean, to me, what always feels like a good signal is if I feel I have to do gymnastics of whatever I'm trying to do to get it to do what I'm trying to do. If all of a sudden I have to write way too much code to do something very simple, I like to take a step back and go, am I really solving this problem the right way? Maybe I am, maybe I'm not. Go for a walk and usually you come back and say, oh, I can do this and realize. Get it.
You can get too focused on the outcome.
I do think one thing that I see more at like slightly bigger companies that might help to facilitate this type of like having that space is, first of all, taking developer time and velocity as like deliverables and kind of key metrics is one thing, but also baking in time for those like, this might not be immediately useful or applicable or might not actually move the needle. 20% time, for example.
Love to be able to do 15% per month.
Google had this, if folks,
Because so many products start as a 20% product.
right, if folks haven't heard of the 20% time thing, like Google and some other kind of Silicon Valley-ish companies would have, let's say, 1 day a week for employees set aside to just work on whatever they wanted to work on, as long as it was somehow related.
They were not allowed to work on their main project.
Right, as long as it was not their
They
main.
could go help somebody
deliverable.
else, but they couldn't work on their main.
Mhm. And this led to like experiments, I think, I want to say Gmail came out of that?
Yeah.
Yeah, okay. Anyway, like at Mapbox, for example, we don't do that because we have this idea that we should be baking that experimentation into everything that we do. We shouldn't be setting it aside as like, this is your time to sit down and be a code monkey. This is your time to go be creative. Like, no, we should be being creative.
You can see why they had to do it, because
exploration.
the culture was not at all conducive to that.
Yeah.
So you're
I
reaping
wasn't
the
there,
benefit, Mapbox is reaping the benefit, I think.
Well, yeah, and so what we do, for example, like on my team, we'll have like once or twice a year, we'll have an offsite essentially where I'll get together and we'll have like a hack day where we do a similar thing and we all just like, we'll work on whatever as long as it's not related to anything we're supposed to be doing. And we do that more like kind of on a sporadic basis and then on a weekly basis, it's like there's plenty of time built into our schedules where somebody can go off and say like, hey, actually, we've been running into a lot of problems with our release tooling. I think we could make these improvements, or we could switch over to this different system, or we could, put this in CI and get some of the manual work out of there. And so I think that there is an advantage to like bigger companies where you have a little bit more leeway, or you kind of have a little bit more kind of runway to spend time working on stuff that's not immediately going to earn you dollars, right? It's sort of like the advantage of being like not having to work 3 jobs so that you're spending like all of your day, all of your week just trying to pay your bills. If you have the advantage of like being able to make a nice livable salary in 4 days a week, then you can take a long weekend and spew on whatever else, write your poetry, do your ceramics, whatever it is. Like it's sort of like that. It's like more resources give you more likelihood to be able to make that space and time. So I would say like maybe that's one way in which big companies do have that sort of advantage. But at the same time, I've seen really small companies like 2, 3, 5 person startups also bake that in if they're lucky enough to be able to, I guess. So yeah. In any case, we can all go petition for it. Or try to make space for it on our own days. It's easy even on the individual level to like lose sight of the importance of that type of work. I find it is. Sometimes you get stuck in the hamster wheel and you forget to take that time to step back and get those whatever, have those go on the walk and have the brilliant ideas.
Take a shower.
Okay, sorry.
Shower thoughts.
I call it rock thinking.
Thanks.
Sometimes you hear that.
So that's different.
If there are no other questions, I think we can take this offline and hang out and maybe make our way someplace downtown. We can grab some more beverages or just hang out in the sunshine. So one last round of applause. Thank you for coming. Yeah, absolutely. Should we do it like outside?
Ooh, yeah, that's fun. Yeah, sounds good.
There's smoke.
Thanks.
Great.
Okay.
And we'll